All right, hello everyone. This is about my sixth time trying to record this video because geopandas is being terrible to install. So hopefully this will work out and this will be a little bit painful. I am sorry to say it's taken me now almost 3 hours to hopefully now get this figured out for you, but before I jump into too much, I just want to say to get this this new starter code, do a git pull on the course materials in Git Kraken, and you should see in starter codes something 6 intro to GeoPandas be there, and that's what I have up on the screen at the moment. I'm going to put the file browser away for now, and then I'm going to go ahead and run this first cell, and you should have an error just like this, where basically it says on this line here, module not found, no module named GeoPandas, and that's because it's not installed in this environment right now. And so I don't know exactly what makes GeoPandas so hard to install and work well with other existing packages, but it's been my experience, not just tonight, but many times throughout my time using it. These geospatial data packages are kind of terrible to install. So instead of trying to do like all these crazy workaround things, we're just going to create a clean environment and start over, basically. Okay, and the way we do that is down here in our little Python console. I'm going to do conda install -- revision 0, and that's going to basically revert the HasTools conda environment back to basically being empty. It's revision 0 is like the very first time you created the environment. And so if I do this, it's gonna go ahead and run, and I'm gonna pause recording here just so that this can do its thing, and I'll be back in a second. Okay, that only took a little bit of time, but here we are. I now have seen, all of this stuff pop out, and then finally at the end it says you may need to restart the kernel, and we're not going to do that yet. We're actually going to, at this point now, type in conda. Well, no, actually that's not true. We do need to I'm going to restart the kernel. I'm going to clear all, and then finally, I'm just going to close VS Code. Then I'm going to open VS Code back up. And this is just to make sure that this goes through and works. So when you pop VS Code back open, you should be met with where you kind of left off. I'm going to shift enter, and it should put you back in HasTools, but HasTools is now empty. And so you should now you should get this pop-up again that it wants to install the IPy kernel package. Go ahead, click install there, and let it do its thing. This one right here should pop up. It's kind of doing some condo looking stuff. We'll let it do its thing, and it's slowly going. While this does this, I'm gonna pause my recording again. Okay, and that took just a little bit of time, and now it's complaining that it can't find NumPy, and that's because we basically emptied out HasTools. This is unfortunate that we have to do it this way, but GeoPandas wouldn't work otherwise. So then we're going to basically recreate the environment. Conda install, and we're going to do a -c for channel. Actually, let's just do -- channel with 1L. Then conda -forge. Conda forge is an alternative place to get your packages, your Python packages or what have you, and it often has a little bit more up-to-date packages. And in the case of GeoPandas, this actually really matters because it's the only way that I could actually make the whole ecosystem work. So now we're going to be installing things from Conda Forge rather than from the sort of base channel, and then we can just start putting our packages. So we need NumPy, we need matplotlib, we need pandas, we need scikit-learn, we need Jupyter, we need geopandas, and then I'm going to add in Fiona and PyOGRIO. PyOGRIO. And those last two ones are basically interfaces to some of the underlying other older implementations of geospatial stuff. And these are actually the reasons, these last three are the reasons that like we have to do this, because they have some like incompatibilities that doesn't work if you just try to do Conda install GeoPandas in the existing environment. And also you need to use Conda Forge for reasons kind of unknown to me, as like the error I was getting was very cryptic. So I'm not going to try to reproduce that for you all. And so again, I'm going to walk through this: NumPy, matplotlib, pandas, scikit-learn, Jupyter, geopandas, Fiona, PyOGRIO. I'm going to let that run. This is going to take some time, so I'm going to pause recording yet again, but this one hopefully will run through, and I'll see you when it is done. Okay, a few minutes later, here we are. Eventually, I got the message, note, you may need to restart kernel to use updated packages. So that is, I'm going to take that advice, restart the hasTools kernel, clear things out, and start from the top. So now we finally can run this, and fingers crossed, you should get the green check mark, and we can start actually learning here. Okay, whew. And just, I'm going to do one final dunk on GeoPandas and throw in another one. CartoPy is another package for like map plotting that we're not going to use here. But again, these packages just break environments left and right. If you're ever going to use this in the wild, in your own research and your own work, I really suggest kind of maintaining a separate environment for them, because otherwise you're just going to have to go through and do this type of stuff. Okay, anyway, so back to the task at hand. When I said do a git pull, I pointed out that we got the starter codes, but we also have these new things in data. So there are two things here. There's two folders called Arizona shapefile and Gauges2 shapefile, and this is what we'll be working with for this intro. And if you look, these are actually folders, so they actually have a bunch of files in them. These are Esri shape files, which is the folks who make ArcGIS and ArcMap. If you're familiar with that, this is one of the popular geospatial data formats, particularly going to be something you'll run into again if you end up going into like consulting, for instance. However, on the flip side, if you end up going more into like the software side of things, you might be encountering other formats of data which can be read in by GeoPandas, like GeoJSONs and so on. But shape files are actually not files. They're a bunch of files. I don't know exactly what's in each of them, and I've never had to find out, and I intend to keep it that way. So I am just going to note that there's one with an extension .shp. That's the one I always will be referring to when I'm trying to open files. So without further ado, I'm going to close the file browser again. I just wanted you to know that that was all in there. And I imported GeoPandas as GPD. and we can use gpd.read file, and then I'm going to point it to this shp file. There is one little thing that probably needs explanation, but I want to run this first, just make sure that I get what I needed. Okay, sure, that seemed okay. You might get this little error type situation where it says proj create from database failed. That's okay. That's just like an initialization type thing, I believe. But you'll note that the file I opened up was ended with .shp. And the thing of interest here that I just want to sort of explain is this ... syntax. So in sort of code file handling, ... means go up one directory. So this this file 6 intro to GeoPandas that we're running, the code that we're running right now, is in starter codes, but we actually need to go back all the way out to course materials and then into the data directory or folder, and then we can go into Arizona shapefile. So again, ... puts us back out into course materials, and then data is this directory, and then Arizona shapefile is this one, and then finally the TL whatever is what I downloaded from data.gov and put in the repo. So then we just point it to that file and that opens it up. And so I'm not going to dwell on that too much, but I read the file in and I just printed out its type so that you can see that this is a geo data frame. And just like pandas has data frames, geopandas has geodata frames. And so I think you can kind of see the analogy here. Geopandas is like just pandas with geometric stuff on top of it. So then, you know, like regular data frame, you can do .head on it just to see the first few entries. And so you'll see that this has a bunch of columns. Scroll down here. And it actually has quite a few columns. For the most part, it's not important what's in here, but you'll note that the end one is called geometry and it has all these polygons in them. And these polygons are the vector data that I was talking about in the previous video. You'll see that things like the INTPT, I'm not sure what that part means, but this has the latitude and longitude. It has something like the area of water and land in each of the polygons and a bunch of other stuff that doesn't matter. The main thing is it has that geometry column, and we can actually look at individual ones by pulling out. So geometry is just a column, right? You can see it has name geometry, so we can actually select out the geometry column. And if you want to just look at an individual one, you can do iLook on it. And there you go. This is some polygon that's in here. This is the first one, but you could also pull out, I don't know, like the 7th one. And so there you go. You can see these individual polygons and they're printed out all nicely. But more importantly, just reset that. More importantly, you know, these individual polygons don't actually necessarily mean all that much. The real thing is plotting the sort of collection of all of these polygons. And so just calling .plot here gets all of them put together, and now you see the state of Arizona. I'm not going to get into what these polygons are because we're not going to actually use them for anything in detail here. But I will note that there was another column in our, when we did .head, you could see a land, which is like the area of land, I believe in square meters, but I'm not 100% sure. But if you want to plot instead of just sort of each of the polygons separately or just plotting them all with the same color, we can color code them by a column. In this case, you just pull it out, and then I'm setting legend equals true so that we get this color bar here so that we kind of know what the numbers mean. Now, unfortunately, they didn't include metadata in their in the column names and things like that. So we don't have a great way to add a very meaningful legend here. So I know I'm breaking my own rule, but in the interest of time, I do want to just keep moving. You can kind of see the big ones have yellower values and the small ones have bluer or purpler values, just as the color bar says it should. So minor aside, this geometry thing, you can actually use it for other stuff. So, you could see each of these polygons individually, and you can do calculations on them. Like if you didn't have this A land column, you could do AZ geometry area, and that will calculate the area for you. And then you can basically plot the same thing and add the color and add the color bar. And then I'm just going to change the color map just to turbo, just so that, we spice things up a little bit. So there you go. This is kind of the same thing. It will complain about the CRS, which we'll see in a second, that this stuff kind of matters. But, this more or less has the same magnitude of numbers up to a constant 10 to the 10th factor as the one that was included. So you can kind of see how this is nice. It lets you work with sort of complicated data in a more easy way. And I also want to pull in this other data set that I alluded to here in data, Gauges 2. And Gauges 2 is a data set from the USGS, and Gauges here is actually an acronym of Geospatial Attributes of Gauges for Evaluating Streamflow. So it's kind of a nice little meta acronym. And 2, I believe, is the second revision here. But it contains data, the full data set contains data from over 9,000 locations of streamflow measurements across the US. And this shapefile only contains sort of like the location and some metadata about them. It doesn't actually contain the streamflow time series because that otherwise would be a rather large data set. But can do GPD, read file. I'm just pointing to the SHP file yet again, and then I'm printing out the head. And so you can see station ID is what this one means. So this is like when we did the Verde River stuff, there was an ID, and then there's sort of like all this nice info, and you'll see this one says Maine, Allagash, Maine. So this is from the entire US, and you can see here the geometry column in GeoPandas tends to be the last one. I think it always is, but I'm not 100% sure on that. But these are all point values, whereas before we had polygons. So now our data is going to be of a different type, but it's still vector data because it varies continuously. And so I can go ahead, just like before, and do plot. And I just added marker size 1 and color equals goldenrod just to make it a little bit easier to sort of see some of the stuff. But here you go. You see this is basically points across the entire US, the contiguous US, we got Alaska, Hawaii, and even Puerto Rico in there. So so this is all 9,000 something or whatever points. And now the next question might be like, okay, we got 2 different sort of data sets and we want to like merge them together and start doing cool stuff with them. So why not just plot Arizona on top of all of these gauges? And if you do this, so I'm just doing gauges.plot, and then to put it on the same axis, you kind of do this one returns an axis, which kind of says right here, and then we'll plot it on the same axis. And I'm just going to set the color to crimson so it's easier to see. And so you can clearly see that Arizona is missing here. It should be, in this area, right? So what's going on? This is basically that CRS stuff coming into play, coordinate representation system. So let me just really try to highlight what's actually going on. And I'm going to basically do the same set of code again, but I'm going to add something in the AZ plot part. So I'm gonna add an edge color of crimson. I don't keep doing that. And then I'm going to set the line width equal to 10. And basically this is just going to kind of expand into a blob what we're plotting so you can see where it is. And so here we go, we're doing this. This will take a second. And Arizona is, I guess, south of Texas. So clearly something wrong here. And this is because if you notice this, these axes labels, they are something to the 6th. And in our Arizona plot before, these are latitudes and longitudes. So we're not using the same coordinate system for these two data sets. And this is actually one of those things that luckily, this is why it's so worth it to jump through the hoops and get something like GeoPandas is we can just do a coordinate transformation with one line of code. So I'm going to put the gauges to data onto a lat long grid rather than whatever this sort of representation is. So to do that, all I have to do is get the CRS from the Arizona shapefile, and that's accessible by just saying az.crs. And then with gauges, I can just do .to_CRS, and because GeoPandas knows what to do, this will just work, and it will return a new geodata frame with the new coordinate system sort of superimposed onto the geometry. And because it's returning a new one, we just assign it to gauges. And then I have this exact same plot function or code from before. So I'll go ahead and run this, and we can now see, boom, Arizona is where it should be. So there you go. That's quite nice. And the next step might be you would want to, we've got this shape file. Like, what if we want to get all of the gauges that are within a shape file, or in this case, within Arizona? So we want to get all of the points. We want to filter out all the points here that don't overlap the red Arizona polygons. And again, GeoPandas is really nice here. We can just do, this is like a clip. We want to clip anything that's inside of this out. So it's basically, like clipping like scissors. We just want to cut out what's in here. And so we can just do gauges.clip, and we're trying to clip this data set to the extent of this data set. So gauges.clip az will give us all of the gauges in Arizona. And then I can plot Arizona, which is just or AZ, which is just the red polygons here. I'm going to make it light gray now. And then AZ gauges is our new set of points that falls within Arizona's boundary. And I can just plot that on the axis. And if I run this, then you will see, bingo, that was easy. This was 4 lines of code to go from, this big thing to just what we want. So this is just showing how nice GeoPandas can be once you've got it up and running. And this is sort of the framework that we'll be working in for your next homework. And we'll merge this with some of your previous knowledge about pulling in USGS streamflow data, as well as maybe some of the DayMet data, or maybe we'll pull in some other station data. But here you go. This is a really nice plot showing where all of the gauges to streamflow data is in Arizona. And this covers almost all of the major streamflow gauges that the USGS operates in Arizona. So there you go. It's been a bit of a thing to get this up and running, but I hope you can see that this is rather nice. And we'll see where we can go from here with it. All right. Thanks for watching.